as well as the Austin. This is a quick update on the Riley. Um, I've got the block back now with the white metal bearings in the rear and in the front cover, which is this piece, have been opened out to fit the new Arrows crank. One thing I do need to work out before I can actually fit this crank is, because this crankshaft is bigger, it won't actually fit through the hole in the front of the engine. It's a bit awkward to see, but it'll get halfway in, and then you can sort of see the hole there isn't quite big enough to get that to slide through. I think it's just because of that little lump on the counterweight there. So you end up needing to relieve the front of the block. I'll just have to sort of grind a groove or some clearance in there. I'm just not sure where the best place to do that is, so I'll get some advice on that, whereabouts the best place to actually remove that material from is, and then I should be able to get the crank into the block. I'll just move this so it doesn't fall down. Get the crank into the block and get the front cover back on. The front cover, you may wonder how it all keeps in alignment. The front cover, this kind of has this lip all the way around it, and that's basically what locates it in exactly the right position into the block. This is one of the reasons I want to be very careful about taking material off the inside of this to get the crank through, because you don't want to screw that up and mess up the registration of that front cover onto the block there. But with the crank in, I should be able to look at temporarily fitting the rods, which are longer rods, and the pistons, and figure out how far up the pistons come, so I can mark off where I'm going to need the faces of the pistons machined. Because the rods are 3mm longer, it'll give me higher compression, which is good, but it means the pistons come up higher in the bores, and you need to machine a little clearance on them so the valves don't hit them, because on the Riley 9 engine like this, the valves are at 45 degrees. It's a hemispherical head. It's all wrapped up at the moment, so I can't show that, but the valves are at 45 degrees, so they come in here and here, so you need to just relieve slightly the sides of the pistons. Once I've done that and I make sure everything is kind of in there and rotating, I need to take all of the rotating assembly to get that balanced. So the other little piece of machining that was done is this new crankshaft. Because it's a thicker diameter, I had to have the taper on the flywheel, which is down in there, machined to suit as well. So that's been done, which means I have a complete flywheel and clutch assembly. Just got a little bit of surface rust on it, so I need to clean that off. But all of that and the crank and the pistons and the rods can all be sent off for balancing. Then with all of those back, I should be able to start assembling this engine. And I think I have everything I need to do the bottom end. I may still need to look at getting some of the stuff I need for the rocker gear. These studs look unused as far as I can tell, when the engine was last rebuilt and then never actually run, so these should be fine. I may take them out and just make sure the threads are all sealed though. I'm not sure if any of these go into the waterways. Yes, they do. So you want to make sure those threads are nice and sealed. It may be worth replacing the studs, I'm not sure. But one of the problems at the moment is, I think, as I mentioned with the Austin, of course the UK is in lockdown. It's also Christmas and New Year, so getting anything is just taking forever. It's really, really difficult. So I'm kind of limited by what I can do. So to fix the change gears in the lathe, which were printed with PLA plastic, that's this black stuff, I've been practicing with printing in nylon, which is this stuff here. And nylon gears will be much, much stronger, they'll last way better. But nylon turns out to be a little bit of a pain to print. It's very, very prone to warping. You also have to print it at a much higher temperature. So I need to print at 250 degrees C in the extruder, and I'm actually getting the heated base up to over 100 degrees C, which I can do easily on mine because I've got a mains based heating element. So the biggest problem with printing nylon is that it warps. You can see from all my test prints, and I've done quite a few test prints, the problem is getting it to adhere and getting it not to warp. So I've been practicing with, or playing around with different ways of getting it to stick to the bed. So normally with PLA I just print on the glass and use glue stick, and that works really well. But with the nylon that just didn't work, it would just lift up. I'm not sure if I've got an example somewhere. I think this one was an example printed just on glass, and you can see how much it lifted. So I started playing around with different ways to get it to adhere to the surface. So there are special build surfaces you can buy. One is a kind of fiberglass type material. There's various other films and things you can use. But I've been playing around with gluing paper to the glass and then putting glue on top of the paper and then printing on top of that. And that's actually worked pretty well. So this was one of the test pieces I did. And you can see this warped as well. But the warping actually effectively delaminated the paper. It tore the paper in half, but flat ways. So the paper is very strong. And, or rather the adhesion to the paper is very strong. And it was the paper itself that wasn't strong enough. It actually sort of split it in half. So getting it to stick to paper works really well. I've tried ordinary printer paper, and the best thing I've found so far is actually brown packaging paper. That's the stuff, it's quite thick. And with a little bit more playing around, what I've discovered is printing a very wide brim stops it lifting. This may be a bit of a pain to clean around the gears, but this was my last test that I did, and unfortunately one of the other problems with printing nylon is it absorbs moisture from the air really easily, and the problem then is when you're printing it, when it's extruding, it will cause pops and bubbles, and it just won't extrude very well. And that's why a lot of these prints have got big blobs of molten burnt nylon on them. That's what this is. And I was trying to clean one of those away and accidentally shifted the glass, which moved, which is why this print isn't clean. But the good thing about this print is it is flat, so I didn't get any lifting on this. So I went ahead and baked my nylon to get all the moisture out of it. You have to be a bit careful when you do that you don't do it too hot, because the plastic reels will deform. So this one was a bit hot, and I've just realized that bag is ripped. So hopefully this hasn't absorbed moisture again. But I'm going to glue down a new piece of paper. I'm going to put on my baked nylon, and I'm going to try reprinting one of these gears and see if I can get it to print nicely again. Well, this is good. It looks like I've managed to print something without it warping. And I also managed to get a much cleaner print by reducing the temperature that I'm printing at down to 230 degrees C, which is apparently the lower limit for this PLA, but that seemed to work pretty well. I've never been exactly sure how good the thermocouples and things are on this printer, so the temperatures are always a little bit hit and miss, I think, which is why they always give you a range. It takes a little bit of playing around to figure out exactly what the right settings are, but this gear's printed out pretty well. The other advantage of printing on paper like this is it's really easy for me to get this to come off the glass. I'm just going to go and soak this in the sink. The paper goes all soggy and the part will just pop off. Often with 3D printing like this, especially on big flat pieces, I've found the problem is usually, one, the part doesn't adhere to the glass and you get curling and lifting on the edges and it just becomes a mess, or you end up with the exact opposite problem and you can get things that end up very, very well stuck to the glass and you can't get them off. So printing on the brown paper like this seems to be working really well. I'm going to print some more gears in nylon because I want to change over the gears in my lathe to be nylon gears instead of the PLA. And I'm going to try printing with PLA on this paper as well, because it may actually be quite a nice sort of build surface. But I'm going to get this one off and I'm going to print some more gears for the 16 TPI that I've got set up in the lathe at the moment, because that seems to be the most common thread that I've been doing recently. And I'll look at what other threads I may possibly need and print the gears for those as well. Other things on the Riley, I got the die, which is over here, to clean up the end of the steering column shaft where the nut that holds the steering wheel goes. This is an odd size, so what's that, 7/8 by 16 Whitworth. That came from Tracy Tools in the UK. So this shows how slow all the postage is at the moment. Obviously it's always going to be slow around Christmas time, but I think I ordered that. It was about the 4th of December and it got here between Christmas and New Year, I think. I'm not sure. It's hard to remember the last few weeks. But I also got some Whitworth taps that I needed, and those were used to that's right, to fit these brake pulley cables. These are the racing style, the Brooklyn style ones that go through this lug on the axle. I needed, I think it's 9/16 nuts to go on the end here, which are really hard to get. It's another one of those things that's really hard to find in New Zealand. I can get them from overseas, but again, it's going to take a month or more just to get a couple of nuts, and it's really expensive. So these are actually 1/2-inch nuts that I just drilled out and retapped for 9/16 using the taps that I got. You can actually see that the casting here isn't completely flat, so that nut isn't sitting completely flat. So I may need to do just a little tiny bit of hand filing on that just to get this all to sit flat. These brake cable pulleys, these housings, take this off. You can see have 2 little holes in them, and that's so you can pin them in place. So there'll be little short pins, and this will be drilled, and that'll lock them in position, which is why I wasn't too worried about tapping through a 1/2-inch nut just to the slightly bigger size of 9/16, because this just has to sort of pull this in, and it's not going to go anywhere with those pins in there. But of course I can't pin it until I know the exact position of it, and I can't do that until the rest of the braking system's in place. So they're just held in there loosely for now. Obviously I need to paint these as well. And I also machined up the missing nuts that go in the foot brake mechanism here. There's 2 nuts that go on the shaft, which goes all the way through here for the handbrake, and they just kind of lock together, and that's what holds this whole mechanism in place. And I didn't have those nuts either, what I did is these pins that hold the shock absorbers on came oversized, and I'd previously machined those down, chopped them off, machined them down, and put the thread on the end so I could put the bolts through. And I had the little pieces left over that I'd cut off the end, so I just machined those up into those nuts and just drilled it through, and then using the lathe tapped out the thread in the middle, which is why I've been doing all the work. I'm still using the PLA change gears in here, but this is why I've been playing around a lot with the nylon gears, because they'll be far stronger and they should just last a lot better than these PLA ones. I'm always a bit nervous doing the tapping, doing the threading on this lathe with these gears, because if these break halfway through, you're going to lose your position. Although I did find out that with machining out these nuts, I did manage to lose the position. The reason this is important is because on this little Emco lathe, I don't have the threading dial, which would normally screw on there. It's something I need to look at. I should be able to make something or do something. So on this lathe at the moment, when you engage the half nut there, you have to leave it engaged when you're doing your threading. So it means never taking this off, and if you do, you'll lose your relative position between the screw here and the chuck, and so your cutting tool won't be in the same place every time you make a pass. And that did happen. I did lose the position, and I found I could pick it up again by getting it reasonably close and then actually loosening the tool in the tool holder. I don't know where the tool's gone. This was the little tool I was using, and I was actually able to loosen it in the tool holder there and adjust the tool to pick up the thread again, and was able to continue from there. Okay, so now I know that trick. I know if you bump it or you accidentally lose the registration, you can get it back. So that worked really well. It's always still just a pain doing the threading on this lathe. It's only really a little lathe, and I have to take very, very light passes and do a lot of them, especially when I'm using a tool like that to cut an inside thread into something, because there's flex in the tools, and it's a painful experience, but it's good that I can do it. I'd be stuck if I couldn't do it. I'd have to buy more taps, I guess. So that's kind of where the Riley's at the moment. I still haven't played with the door. I have been setting up the mill so that I can mill the slot in the rear suspension hanger pins. And that was because this tube that's on here, even though it's thick-walled tube, it's not seamless. So there's a seam inside there, a little tiny ridge where it's been welded together. So I want to machine a groove in the pin that slides into there to clear that weld, because I don't have any way to machine this to make sure it's perfectly concentric. Even if I could get this bar out, which I don't think I can, I think it's welded in, my lathe's not big enough for me to be able to put that in the lathe and turn that down. So if I machine that groove in the pin and then turn the pin down so it's a nice tight fit in there, lots of Loctite, and then it's pinned through, that should be held in there quite nicely. It's just a matter of actually setting it up on the lathe and doing it. So I've got my center finder out and figure out the exact center of it. This is actually my the first pin I made, which I did wrong, and so it's a bit undersized here, but it's a good test piece. So I'm going to mill the clearance slot in this, and then I'll turn this down very carefully and keep checking it against the chassis until I get it to the point where it's a nice sliding fit. The Austin is now pretty much ready to take to be certified or revinned. The last few little bits and pieces have all been done. The bonnet straps are on, the catches are on, Joss gave me a little clip when I was up visiting in Auckland, which is on there, which holds that little cover in place. And I made a mounting for the number plate. I fiddled around with this a lot, trying to figure out the best place to put it, because there isn't a lot of room on the back of the car. So one option was up here, but I didn't like how it looked because it goes over the guard, and I didn't like that look. And also I have to mount reflectors on here. That's the one thing I still need to do to get the car ready for registration. I'd forgotten about that. I do have some temporary ones I could put on, which is probably enough to get it through, but I've ordered some proper Lucas style. I think they're Lucas RER2s, which have a rubber base that's angled, black rubber base, which will fit on here. They're specially designed to go on sloping guards. So in the end I settled for putting the number plate here, and I made up a back plate out of steel, which is basically the exact same size and shape as a New Zealand number plate. I ran it through the bead roller just to put a little lip on the edge to make it a bit stiffer, and the number plate will basically bolt to that. And the reason I wanted to have the backing plate is just so it'll look nice and tidy from the back here. I didn't just want to see the rear side of the number plate, which is just raw aluminium. And there's a little bracket down here that bolts it to the guard. And it's a bit hard to see, but maybe from the side. I actually welded a piece of tube that's flattened either end onto that to make this a lot stiffer, because everything in the car vibrates. So the plate will probably still vibrate a bit, although it'll be better once I've got the actual plate bolted on there. But that stiffened everything up. That basically seemed to be the most out of the way place. I can always change it later, but anywhere else didn't really seem right. It's just a funny shaped car. And then the last thing I've done is fitted my nylon gear train to the lathe, and I think these are going to work a lot better. It should be okay. They should hold up far better than the PLO ones, I'm hoping. I'll just have to wait and see. But disengage that. Here we go. I think that's it. Oh, the one last thing I want to do for the Austin, which I may go and do now, is I'm going to paint that number plate bracket. I'm probably going to remove the fuel filler cap, paint that at the same time, and I'm going to laser cut a new gasket for that. And I also want to laser engrave my fuel stick. This is just a temporary stick so I can measure the fuel levels. So I'll do that on the laser as well. I want to get hold of some, it's called vulcanized something, vulcanized fiber, red fiber, which is what the original Chummy fuel sticks were made from. But I need quite a long piece to reach into my fuel tank, and I haven't worked out where I can get some of that from yet. It's basically the same stuff they make those little red fiber washers from. Works really well as a fuel stick, so I'll have to see where I can get hold of some of that. This is my test fuel measuring stick. I think this bit of wood is just a little offcut of pine, I think. Same sort of stuff they make trellis from. I really want to find a nice piece of hardwood or something a bit better that I can actually make the gauge from, but that was my quick go at laser engraving it, and that came out okay, except I got a bit wonky. And basically you use it like that. You can see how much fuel there is. It's only rough, of course, but it gives you a pretty good idea. So it's I think it was about 22 litres completely to the top. Something like that anyway. But yeah, you can see that works. I couldn't get the fuel filler off. This, where it's attached to the rubber hose, I can get these bolts out okay, but the rubber hose is sort of stuck on there at the moment, so I'm just going to leave that how it is for now. And I've taken off the number plate bracket because you probably can't see it, but it's hanging up over there, painted and the paint's drying. And I may or may not, I'm not going to admit to anything, have gone for a sneaky drive around the block in this, just to make sure everything was working and nothing was going to fall off. I had an excess of limes and I needed to solve that problem. So that's all we'll say about that.